Good morning, everyone. Myself Sheetal Fatangre, Assistant Professor in Vishwakarma Institute of Technology, Pune. In today's session, we will see some basic concepts related to compiler design. So, before starting with the phases of the compiler design, first we will understand that what is compiler, what is interpreter, what do we mean by the language processing system, how it can be executed, and then the introductory part related to the phases of the compiler. So now, what is compiler? A compiler is a program that can read a program in one language called the source language and translate it into an equivalent program in another language called the target language, which is shown in the figure. So, an important role of the compiler is to report any errors in the source program that it detects during the translation process. So, here, if the target program is an executable machine language program, it can then be called by the user to process the input and produce the output. So, based on this, what is an interpreter? Basically, an interpreter is another common kind of the language processor which scans the source program line by line. So, instead of producing a target program as a translation, an interpreter appears to directly execute the operations specified in the source program on the inputs that will be supplied by the user, which is shown in the figure. So, here the machine language target program produced by the compiler is usually much faster than the interpreter at mapping inputs to the outputs. So the interpreter can usually give the better error diagnostic than the compiler because it executes the source program statement by statement. Then the next one is what is the language processing system? So here, in case of the language processing system, with the compiler, several other programs may be required to execute an executable target program, which is shown in the figure. So here, a source program may be divided into the different modules, which is stored in the separate files. So what are the different modules over here? That is the preprocessor, the compiler, the assembler, the linker, and the loader. Then, what is the preprocessor? Here, the task of the preprocessor is to collect the source program into the separate program called the preprocessor. The preprocessor may be called as a macros into the source language statements. Then, what is the compiler? Here, the modified source program is given as an input to the compiler. The compiler may produce an assembly language program as its output because the assembly language is easier to produce as the output and it easier to debug. With an assembler, an assembly language is processed by the program, which is called as an assembler, that produces the relocatable machine code as its output. The large programs are often compiled into the pieces. So, the relocatable machine code may have to be linked together with the relocatable object files and the library files into the code that actually runs on the machine. So that can be done with the help of the linker and the loader. So basically, the linker resolves an external memory addresses where the code in one file may refer to the location into another file. The loader then puts together all the executable object files into the memory for an execution. Based on this, the structure of the compiler is divided into the different phases. What are the different phases? These are the lexical analyzer phase, the syntax analyzer phase, the semantic analyzer phase, an intermediate code generator, a code optimization, and the target code generator. So here, the compiler maps the source program into a semantically equivalent target program. So when we will say that it will be semantically mapped to the target program, it is divided into the two types. Which are the two types? These are the analysis phase and the synthesis phase. The analysis part breaks up the source program into the pieces and impose a grammatical structure on them. If the analysis part detects that the source program is either syntactically wrong or wrongly formed or semantically unsound, then it must provide an informative message so the user can take the corrective action. Basically, an analysis part also collects an information about the source program and stores it into the data structure which is known as a symbol table. So here the symbol table is shown where we can store such type of the information. A synthesis part constructs the desired target program from an intermediate representation and the information into the symbol table. So we can say that an analysis part is often called the front end of the compiler and the synthesis part is called as the back end of the compiler. So here is shown in the figure, the sum of the phases will work like an analysis phase and some of the phases will work like a synthesis phase. That is the front end and the back end of the system. So here the lexical analyzer, the syntax analyzer and the semantic analyzer will work as a front end of the system, whereas the last three phrases, that is the intermediate code generator, code optimization and the target code generator will work as a back end of the system. So what are the different phases of the compiler? So here we will see just the introductory part related to the different phases of the compiler. So there are total 6 phases of the compiler. That is, the first phase is lexical analysis phase. The second phase is syntax analysis phase. The third is semantic analysis phase. The fourth is intermediate code generation. The fifth is code optimization. And the sixth is the code generation or the target code generation. So here, what is the lexical analysis phase? So here it is shown with a diagram. The first phase of the compiler, which is called as the lexical analysis phase, or we can say it is the scanning phase. The lexical analyzer reads the stream of the characters as a source program and groups the character into the meaningful sequences called the lexems. The second phase is the syntax analysis phase. So here, the concept of the parser is used. The parser uses the first component of the tokens produced by the lexical analyzer to create the tree-like structure. a typical representation of the syntax tree in which each interior node represents the operation and the children of the node represents the arguments of that operation. The third phase is semantic analysis phase. So the semantic analyzer uses the syntax tree and the information into the syntax tree to check the source program for the semantic consistency with a language definition. It also gathers the type information and saves it in either the syntax tree or the symbol table for subsequent use during the intermediate code generation. An important part of the semantic analysis is the type checking, where the compiler checks that each operator has matching operands. The next phase is intermediate code generator. Here, in case of the intermediate code generator, the process of translating the source program into the target code, a compiler may construct one or more intermediate representations, which can have the variety of the forms. So the syntax tree is one of the form of the intermediate representation. So basically they are commonly used during the syntax and the semantic analysis. Here with the figure, the intermediate code generator is shown with a 3 address code representation. So there are the different representations we can use. For example, the syntax tree representation, the 3 address code representation, the quadruple representation, and the triple representation. Then the next phase is the code optimization. Here, the machine independent code optimization phase, which attempts to improve the intermediate code. So the better target code will get result. A simple intermediate code generation algorithm followed by the code optimization is reasonable way to generate the good target code. So as shown in the figure with an intermediate code generator, so we will require the 3 temporary variables, that is the T1, T2 and T3. With an optimization, we will reduce some code. So with the help of the one temporary variable, that is T1, we can optimize the above code. Then the next phase is the code generator. So basically, the code generator takes as an input as an intermediate representation of the source program and maps it into the target language. If the target language is machine code, registers or the memory locations are selected for each of the variables that will be used by that particular program. So the intermediate instructions are translated into the sequences of the machine instruction that perform the same task. So here with an example, each and every phase will work and what type of the output it will produce, which is shown in the figure. For example, the lexical analyzer will generate the tokens. The syntax analysis phase will generate a tree-like structure. The semantic analysis phase will check the semantics of that particular language. With the intermediate code representation, we can represent that particular code with the help of the syntax tree or the 3 address code, and that particular code will get optimized. And with the code generator, with the help of the instructions like addition, multiplication, store, what type of the registers that will be used, that particular information will get generated. So this is all about the introductory part related to the 6 phases of the compiler. Thank you.